right, number 20 here gives us a velocity graph. So this is v of t for some object. First one says, when is the object moving to the right? So we're going to move to the right when our velocity is positive. This is the velocity, and this is positive from 0 to 2, and again from 6 to 10. Okay. When is the object moving to the left? We'll be moving to the left when our velocity is negative. Okay, so since this is the velocity, this is negative from 2 to 6. When is the speed of the object increasing? So again, there's ways to kind of do this with acceleration and velocity together, and so if that makes sense to you, go for it. For me, when I'm looking at a graph, I'm saying, when is my speed increasing? Well, am I going towards 0, a speed of 0, or am I going away from a speed of 0, right? So like from 2 to 4, I'm going away from 0. I must be speeding up from 2 to 4. Okay. From 4 to 6, I'm heading towards 0, so I must be slowing down. But from 6 to 8, I'm moving away from 0. So from 6 to 8, my speed is increasing. Right? And so again, if you're looking at a graph, it's just as simple as saying, well, am I moving towards 0 or am I moving away from 0? And that gives you an idea. When is the acceleration of the object positive? Now, acceleration is change in velocity, right? So it's when v prime of t is positive. Or another way of thinking it is when v of t, when the velocity is increasing. Whenever velocity is increasing, the derivative slopes will be positive. That's what acceleration is representing. So when is acceleration positive? When this is increasing, which looks like from 4 to 8. This one says, when is the object furthest to the left on the interval 2 to 10? So look at our problem from 2 to 6. We have a negative velocity, which means we're moving to the left from 2 to 6. And from 6 to 10, we have a positive velocity, which means we're moving to the right. Question says, when are we furthest to the left on this interval? So if we've been moving to the left, we're moving to the left, moving to the left, moving to the left, all the way from 2 seconds to 6 seconds, and then at 6 seconds we stop, we turn around, we come back, then it must be at 6 seconds that we are the furthest to the left. So we would say at t equals 6 seconds. Okay. Can we make a sketch of the possible position function on the same graph? Now, we don't have any idea where that position is at, where we start. We don't have an anchor point. We do know that from 0 to 2, we were moving to the right. We were increasing our position. So I'll just start it here. It doesn't matter. But from 0 to 2, our position is increasing. Okay. From 2 to 6, our position is decreasing. So we're going down till 6. And then from 6 to 10, our position is increasing again. So something like that. All right. Doesn't matter if it's oriented up here, down here, in the middle. We have no idea where the positions are at any time, but it would have a shape, something similar to that. Okay. All right, last page here says we have a derivative graph, and the first question is, where is f of x increasing? So f of x is increasing when f prime of x is positive. This is f prime of x, and this is positive from, it looks like, negative 2 to 0. Now, if you said negative infinity to 0, we would accept that too. But we'll go negative 2 to 0. Where is f of x at its maximum from negative 2 to 2? Now, starting at negative 2, we are increasing. We have a positive derivative, which means f is increasing all the way to 0. All right, and then it has a negative derivative for that, which means it's decreasing from 0 to 2. So we were increasing all the way from up to 0, decreasing then down to 2. So we would say that at x equals 0, that's where we hit our maximum. Okay, based on what we know about this. Where is f of x at its minimum? Now that's a little trickier because we started at some place for negative 2 and then started to increase, and then we came down and we stopped at 2. So maybe we're at the minimum at the very beginning and then we ended somewhere higher, or maybe we decreased past it and we're somewhere down here. So we don't know that officially, so we would say either at x equal negative 2 or at x equal 2, and we don't know which one at this point it would be. Now when we get to chapter 4 and we talk about integration, you'll find the area under this is actually how much it increased. The area under here is how much it decreased, and then we can compare that to get an answer. But at this point today, we don't know the difference between that. Is f of x differentiable at -1 at 1? Now this is really sneaky. This is the graph. So if the question said, is f prime differentiable at -1 and 1, we would say no because of the sharp turn. Okay? But that's not what this question is asking. It said, is f of x differentiable? In other words, is there such a thing as f prime -1 and f prime 1? And the answer is yeah, they're right there. We do have f prime -1, f prime 1. So we would say yes. But if they wanted f double prime -1, f double prime 1, those are undefined because of the sharp turn. So kind of a sneaky problem. All right. And then the final question says, where does f of x cross the x-axis? They want to know if this is the derivative and this is how it moves, this is where it increases, this is where it decreases. Well, where does it hit the x-axis? We were given no anchor point. We were given no idea where this thing is at any time. So where does it cross the x-axis? I don't know. I have no idea because we weren't given anything, any clues as to where it might be at any time.